So we've looked at mechanical weathering where either ice or roots or animals can break up a rock, or even pressure can break up a rock into smaller pieces. Chemical weathering is really a chemical reaction. So normally it's something that's happening on the chemical level where the materials are interacting. And because of this, you have something new at the end. There's a product that's different from the reactants. And the one that I can think of mainly, or even only, is acids. So if you were to have acids in the rain, let's say acid rain, you've heard of acid rain. Essentially, any kind of even carbon dioxide in the air can mix with the water in the air to form an acid. And an acid can react to certain types of rocks. And what will happen is it breaks down those rocks. So carbonic acid comes from carbon dioxide plus water, and it forms a material called carbonic acid. This carbonic acid, if it hits anything that has carbonates in it, okay, which is a type of rock like limestone, it'll bubble away that limestone. It'll actually eat it away. So if you've ever thought of acids, you can use acids to clean metals. You can use acids to break down substances. So it's very, very effective at doing this, and it can break down minerals inside rocks. It can actually make the minerals soft and gooey, and they just break down. And so the chemical weathering is to make it different than the mechanical. You don't have the same stuff at the end. It's not just that it's smaller, but that it's actually altered in some way. Okay, so if you were to have an acid or even some other kind of oxidation, and an oxidation, if you've ever seen a rock that is clean when it's cut, let's say they cut to build a road, they cut a cliff, and it's beautiful stone when it's cut, and then after several years it's black and cruddy. What's actually happened is the air has reacted with some of the minerals. So it's not just acids, but it's some kind of a chemical reaction that's occurring with the surface of the mineral and something in the environment. And that can change the actual stuff that's in that rock and change it into something else. So, for instance, feldspar minerals, okay, can be broken down into what we know now as clay. It's usually at the bottom of a pond or bottom of a stream, and you can go down and reach in and get a big it's gooey mud. But it's not just dirt and water, it'll hold water. Okay, so you know the difference between mud and clay, but you can kind of still play in the mud. It's pretty cool. You can break apart certain types of rocks chemically. Other rocks really don't respond. So, for instance, quartz. If you put acid, you could soak quartz in acid, in strong acid, and nothing would happen. It wouldn't do anything. In fact, you make beakers in a chemistry lab out of glass, which is the same thing as quartz. So certain minerals do not chemically break down, but other minerals would. So in the case of, say, an underground cave or cavern, certain minerals would not move at all, like sandstone, which is all quartz, would not move at all, but the limestone that might be under it would be eaten away into a cave. So Carter Caves in Kentucky has a flat roof of sandstone, but a cave that looks like a square walled room underneath that sandstone ceiling, because the limestone was eaten away under the sandstone by the acid in the water that seeped through the ground. It didn't affect the roof at all, but affected and made a chamber inside it. So certain things are resistant, other things are not, which makes it really cool. And things like caves and caverns especially are awesome. So here's a table to maybe help you, okay? If you break down quartz, okay, mechanically broke it down, you just have little grains of quartz. Well, quartz essentially is little shreds of silica. It's a silicate. So silica and oxygen, so some kind of an ore of silica or silicon. Okay, feldspars and amphibole will break apart into silica. Remember, they have silica in them, but they also have whatever was mixed in the feldspar. So if it was calcium or sodium or potassium, that will come out as it's broken down. Okay, so they will break apart, and you end up with a chemical weathering where you end up breaking apart what used to be a rock into the ions that made up those rocks. Okay, so then those ions can have chemistry in the stream or in the ocean, all kinds of stuff happening, or in the ground with other materials. Okay, so olivine, remember, is mostly silica, but there's also other, usually metals in it. Okay, so it could have iron in it, it could have magnesium in it, it could have all kinds of different things in it. That's what gives these rocks like olivine the color. Okay, so you have the green color. If it was only silica, it would be a pure glassy color. It would be transparent. But all of these minerals would break apart too if they're chemically weathered. So this is just a slide of review. Mechanical weathering breaks down a rock into smaller pieces of that same rock. Its composition doesn't change at all. But what it does is it makes the surface area bigger in proportion to the inside. So the outside compared to the inside is bigger. Okay? The smaller the rock, the more outside you have compared to the inside. Well, that gives the outside more of a place for a chemical reaction to occur, because a chemical reaction occurs at the surface of a material. And so then mechanical weathering could lead to more increased chemical weathering. Okay, so mechanical weathering, remember, was ice, which is called frost wedging, sheeting, which was an intrusive rock, which is pressurized from the inside, but there's no top to it anymore because of erosion, and so it's expanding, and the rock can't expand, so it breaks and cracks. Also, tree roots and animals can also break it apart. The next question is, how does chemical weathering break it down? Well, oxidation is, remember, oxygen reacting with the water in the air, okay, and that attacking the outside of, say, the rock. That's what made the rock scuzzy and dark and brown. When at first, when you cut the rock, it was nice and clean and light colored. Then it might become dark colored later. That's by air oxidation. Also, acid, especially carbonic acid, which is carbon dioxide mixing with water and then becoming an acid and then attacking anything with carbonates in it, can change the structure of the crystal into something new and actually break it down into its component parts.